Hello and welcome to the Tetra Elements LLC YouTube channel, where we specialize in solving complex engineering problems with cutting-edge simulation tools. I'll guide you step by step through the meshing process for a hinge part in Ansys. If you need assistance with your projects, feel free to reach out to us at www.tetraelements.com. We're here to help with your simulation needs. Now, let's dive in. Okay, first, open Ansys Workbench. Once the software is loaded, you'll see the project schematic. From here, drag and drop the mesh module into the workspace. This is where we'll upload our geometry and perform the meshing process. Alright, now upload your hinge geometry into the mesh module by right-clicking on the geometry cell and selecting Import Geometry. Once the geometry is imported, double-click on the mesh cell to open Ansys Mechanical. This may take few seconds. Once Ansys Mechanical opens, you'll see your hinge geometry. Let's start setting up the mesh. Our goal is to create a high-quality mesh that ensures accurate simulation results. Alright, under the Details of Mesh panel, make sure the physics preference is set to mechanical. Alright, set the element size to 2 mm. This provides a good starting point for the mesh density. Check the default sizing options. Ensure adaptive sizing is turned off and that capture curvature is set to yes. Alright, let's fix these. Alright, now leave the mesh ungenerated for now. We'll return to this step after completing the other setups. Multi-zone meshing is crucial for controlling the mesh structure in regions that require high accuracy. To enable this, in the outline tree, right-click on the mesh and select Insert Method. Okay, in the Details of Method panel, change the method to multi-zone and scope it to the hinge geometry by selecting the body. Okay. Make sure that the mapped sweep type is set to hexa, and also ensure that the free mesh type is set to tetra pyramid. Alright, leave the sweep settings as default for now. This setup will help create structured meshes in specific regions of the hinge geometry. Inflation layers improve the mesh resolution near critical surfaces, such as boundaries. Okay, right-click on the mesh and select Insert Inflation. In the Details of Inflation panel, scope it to the geometry by selecting one body. For the boundary scoping method, choose Geometry Selection. Select these boundary faces. Let me select those. Okay? Set the inflation option to Total Thickness from drop-down menu. Alright. Set the number of layers to 3 and the maximum thickness to 7 mm. And leave the growth rate as 1. Great. This ensures a smooth mesh transition near these faces. Okay, now let's add a second inflation layer for different regions. Right-click on the mesh and select Insert Inflation. Okay, in the Details of Inflation panel, scope it to the geometry by selecting one body. This time, select these 8 faces. Let me select them. Set the inflation option to Total Thickness. Set the number of layers to 3 and the maximum thickness to 3 mm. This step helps refine the mesh near smaller or more detailed regions. Okay, we made a good progress. Alright. Now that we've set up the multi-zone and both inflation layers, it's time to generate the mesh. Right-click on the mesh in the outline tree and select Generate Mesh. This may take few seconds. Okay. We got it. Once the mesh is generated, check the Mesh Metrics panel. Go to Mesh, Quality, and from Mesh Metric drop-down menu, select Element Quality. Ensure the minimum mesh quality is higher than 0.2. This is critical for achieving accurate and stable simulation results. Alright, in this example, the mesh metrics confirm that the minimum quality exceeds the threshold for majority of the elements, indicating a well-optimized mesh that is good for the accuracy we are looking for. Alright. That wraps up our tutorial on meshing a hinge part in Ansys. Remember, a high-quality mesh is the foundation for reliable simulation results. If you have any questions or need further guidance, don't hesitate to comment below this video or contact us at www.tetraelements.com and get 30 minutes free virtual consultation. We're always here to help with your engineering challenges. Don't forget to like, share, and subscribe to our channel for more tutorials. Thank you for watching, and we'll see you in the next video.